Okay, today we're talking about sinusoidal applications. Basically, these are real-life situations that can be modeled with a sine or a cosine graph. Okay, the first thing that I can use is a minimum and a maximum. This will help me find all of the important information to write an equation. I can also use it to help me graph, but in this case, the graph was given. When I find the distance between the x's, so here's my x1, here's my x2, that's half of a period. So think of it this way. If I'm on a Ferris wheel, here's the minimum, okay? And as I go around the Ferris wheel to get to the top, I have gone 1/2 of a period, okay? So the distance, the horizontal distance from here to here is half of a period. So I take pi over 2 and I subtract pi over 6. I got to have a common denominator, so that's 3 pi over 6 minus pi over 6 to give me 2 pi over 6, which is pi over 3. So half a period here is pi over 3. Now, I don't really need that half period other than to multiply it by 2 to get the period. So my period is going to be 2 pi over 3. The frequency is when I take 2 pi and divide by 2 pi over 3. When I divide by a fraction, I multiply by a reciprocal. And so I am left with a frequency of 3. So 3 rotations between 0 and 2 pi, or within 2 pi. Also, distance between the y's. So from here to here, that is my range. So that's -1 to 1. I can find the average of those y's, and that is my midline or my vertical shift. Those are both the same thing. So I take -1 and I add 1 and I divide by 2 and I get 0. So I actually have no vertical shifting and my midline is at y equals 0. The difference between the maximum and the midline is my amplitude. So I can look at my graph and find it, or I could just say, okay, if my max is 1, 1 minus 0 is 1. So my amplitude is 1. And because I have a graph, I can clearly see that it starts at 0, 0, and it looks like a negative sign function. So I use these clues to help me write the best equation. Sometimes those clues aren't given, so you may have to do a phase shift. Since you know you have a minimum and a maximum, you could do a cosine with a phase shift. So the easiest one here, based on what is given, all that is given, is a negative sine of 3x. But if I didn't have a graph and all I knew was a minimum right here, then I could say y equals a negative cosine of 3 times x minus pi over 6. Okay, I could do that one too. They're both very valid equations. All right, so here's another example without a graph. I can sketch the graph. So I have 1, 2, 3, 4, 5, 6, 7, 8. So that means I'm going to start on the y-axis with the maximum. That's an indication of a cosine function. That would be the best one to use. And then after a distance of pi, I have a point at -2 right here. Okay, so from my maximum to a minimum, that's a distance of pi. So that means my period is 2 pi. Okay, then I have a frequency of 1. Next, I take the average of the y's. So I have 8 plus -2 divided by 2 is going to be 3. So my vertical shift, or my midline, is at 3. So right here, 1, 2, 3. Okay, I take my maximum to get my amplitude. I'm going to take my maximum of 8 and I'm going to subtract my midline, and that gives me 5. So my amplitude from here to here is 5, and here to here is 5. Now I should have enough to write my equation. I have my frequency, I've got my midline, I've got my amplitude. There's no phase shift here because the max is on the y-axis, so I have y equals 5 times the cosine of x plus 3, and that is the best equation. If I wanted to write a sine function, I could figure out what's halfway there, so halfway between these would be pi over 2, and at pi over 2, it's going to be right here on the midline. So this would be pi over 2 and 3. So I could write a sine function. It would have to be a negative sine function. Y equals a negative 5 sine of x minus pi over 2 plus 3. I could also use that as well. Okay, the other cool thing about these applications is they can give us an equation such as this, and we could find all this information. Now sometimes, and especially in the case of this one, a calculator is very, very helpful. But let's pick out what we can before we get the calculator involved. Notice there is no vertical shift here. So my minimum is going to be a negative 160. My maximum will be a positive 160. The range would be from negative 160 to positive 160. The frequency is what is in front of the variable, so that's going to be 500 pi. And the period is going to be 2 pi divided by 500 pi, which leaves me with 1 out of 250, which is like 0.004. So yes, that one period, that means one rotation or one cycle right here is actually a distance of 0.004. Super, super tiny. Y-intercepts, that's when x is 0, and the x-intercept is when the y is 0 on the x-axis. Okay, so this is some information. Now, when I go to my calculator, I can create a window. So let's say my y, these are for my y's. So my y max is going to be 170, and my y min is going to be a negative 170. For x, let's start at 0, and our max, well, think about it this way. If one period is 0.004, then two periods would be 0.008. So let's just do 0.008, so we can only see 2 periods of this function. All right, so I already have this in my calculator right here. And I want to show you how to use the calculator to find these pieces of information. So if you hit second, so first of all, make sure that you're in radian mode. Got to be in radians. Then you make sure you type in your equation properly. All right, then you go to second and trace. And this right here, calculate, you've got value 0, minimum, maximum. Well, we're going to start with our minimum. So I'm going to select 3, and then it asks me for boundaries. Well, this is not a minimum, so I need to go down here to my first minimum. So I arrow down to something that's just left, press enter. It's going to pop that little line. And then I want to go to the right side of that minimum, hit enter, and then hit enter through the guess. And then it tells me that at 0.003, I am actually at that location of negative 160, or sort of approximated there. All right, the minimum, I go to second and trace, and I'm going to do the maximum now of 4. So again, this is a minimum. It tells me at the top of the screen that I'm looking for a maximum. So I'm going to arrow over to this first maximum, just a little bit to the left, and a little bit to the right, hit enter through guess. And this is like such a tiny number. It's pretty much like 0. But we'll put 6.6 times 10 to the negative 4th. So it's not quite 0, but it's super close. And I would use these for depending on the context of the question. So let's say they say after 1 revolution, when would it reach its max again? Then I would look for this max. Or after 2 revolutions, then when would it reach, you know, a certain minimum again? Again, that's when I would figure out which of these minimums I want to find. Okay, the other cool feature is your y-intercept. So this is when you have a value of 0 for x. So this number 1 is a value that you choose for for x. So click on the value, and notice it says, what do you want your x to be? Well, it doesn't really say that, but we're just going to put a 0 in there, and that gives us our y-intercept. This would be questions like at time 0, when did this function, or where was this located when the time started at time 0? And so this will be like 81.02 units of whatever it is. Okay, so again, the Tarzan problem that I proposed, this is that question, where was Tarzan when Jane started the stopwatch? Okay, that's what this is going to tell you. Okay, the last thing is your x-intercepts. Those are called zeros. We saw those back in Algebra 2 when we were trying to find the x-intercepts or the zeros of a function. So if I click on that, again, it's going to give me my left bound, right bounds. So I just need to figure out which ones I'm looking for. You might be asked for a couple of them, and that's cool. Okay, and any kind of intersection would work. Now, the other thing is sometimes there's a certain y value that you're supposed to find. So in our case, we're going to make a line called y equals 0, but it could be anything else, like y equals 120. How long did it take to get to a height of 120? So when I go to graph that, that puts that line right there. Now, if I wanted to find the intersection of these two functions, which just happens to be the zeros, then it's very, very similar. Okay, I'm going to go second and calculate intersect instead of zeros, and I'm just going to try to find these intersections. So I scroll and scroll. The first curve is here, the second curve is there, and because it's kind of around this area, it's going to look for that intersection right there. No guessing. And so my intersection right here is going to be 0.00, 0.01, or we'll just say 2. Okay, again, I could find the others over here if it was asking. Or I could do my zeros. So if I go back to y equals and I cleared this out, and I just went to calculate a 0, I'm just going to go to the left side. So I'm going to arrow over again right here, just a little bit to the left of that intersection and to a little bit of the right, so that between these two boundaries there's the 0 I'm looking for, and it's exactly the same. It does give it in some scientific notation, but ultimately that is also 0. Okay? Alright, so you guys work on the application, do a couple practice, go back and revisit the Tarzan, and I hope this kind of opens up some really cool things for you.